An improper integral is when we have an unbounded integral. So in this case here, we're going to integrate from 1 to infinity of this 1 over root 1 x minus 1 function. Now it is unbounded on two sides here. So it's unbounded as we approach x equals 1 from the positive side, and it's unbounded as we approach x equals infinity. So we're going to need to split this up, and we're going to arbitrarily split it up at x equals 2. Now you could split this up anywhere you want, but just chose 2 since it's a convenient number. So we need to do this, use a limit to do this properly. So we're going to take the limit as, and we're going to change this to, let's rewrite this, we're going to change this to a. So limit as a approaches 1 from the positive side. So that's going to be our lower bound. So we're going to change the x equals 1 into a, and we're going to approach it from the left right hand side, and we're going to integrate it to x equals 2, and that's going to be 1 over square root x minus 1 dx. So then we're going to add that to the area from 2 to infinity. So we're going to need a limit as b approaches infinity, and we're going to let the right hand bound be b. So we're going to start at 2, and we're going to go to b, and b is going to approach infinity, and it's the area underneath the same curve. So we're going to anti-differentiate the same curve. Okay, so taking this, we're going to anti-differentiate this. So again, we want to keep our formal limit notation. A goes to 1 from the positive side, and the antiderivative of this is going to be x minus 1 is going to be to the power 1/2 times 2, so we're going to divide by 1/2, and we're going to evaluate this from 1 to 2 as 1 approaches 0, as a approaches 1 from the positive side. Okay, and then plus, the antiderivative is going to be the same. The limit as b approaches infinity, and we're going to anti-differentiate this, so we get 2x minus 1 to the power positive 1/2. Okay, and then we're going to evaluate this from 2 to b, which approaches infinity. At this point, we're going to substitute in and work out these areas. So I'm going to substitute in 2. So this becomes 2 times 2 minus 1, so 1 to the power 1/2, minus, as a approaches 1 from the positive side, this is going to be 0. So this works out to be 0. Okay. And then plus the area that we're going to work out here, I'm going to plug in my upper bound is going to be infinity, so this is going to be 2 times infinity square root, which is basically infinity, and we're going to plug 2 into here, and we're going to minus 2 times 1, and so that becomes 1 to the power 1/2. So I'm going to write that in 2 times 1 to the power 1/2. Okay, so these two pieces just end up canceling out anyways, but we end up with, when we sum this all up, we get a net sum of infinity. Okay, so this is infinity on this side, this becomes an area of 2 on this side. So if I were to do this separately, this unbounded piece here has an area of 2, so it has a finite area. This area on the right hand side is the unbounded area, has an infinite area, so the total area is infinite.